Okay, so our new problem is 545. The mobile crane has a weight of 600,000 newtons and center of gravity at G1. The boom has a weight of 150,000 newtons and center of gravity at G2. If the suspended load has a weight of 80,000 newtons, determine the normal reactions at the tracks A and B. For the calculation, neglect the thickness of the tracks and take theta is equal to 30 degrees. Okay, so we have a crane. It's carrying a load of 8 tons. The crane, the body has a weight of 6 tons, 60 tons, and the boom has a weight of 15 tons. So the angle theta is given. Um, it is told us that the thickness of the tracks will be neglected. Therefore, we will assume that there are some reaction forces coming at A and B coming from the ground, right? As a result. So we have the weight here, weight of the crane, weight of the boom, and weight of the object. We are given the dimensions. So the distance between the G1 and A is 1.333 meters. Distance between the joint of the boom to the center of gravity of the crane is 2 meters, and distance from center of the track B to the joint is 1 meters, and the total length of the boom is 9 meters. Okay, let's draw the free body diagram. So this will be the first step, in fact. So let's say that the force coming from the ground to the track A is Fa. And the weight of the crane is WG1. Force coming from the track ground to the track B is FB. I just choose an arbitrary direction. I choose them upwards because this is logical. The weight of the boom is WG2, and the weight of the object that's carried is W. The angle between the boom and the vertical horizontal axis is theta. I say that this distance is A. So A is 1.333. So we have B. B is 2 meters. We have C. It is 1 meters. D is 4 and E is 5. Certainly, we choose horizontal axis as X and vertical axis as Y. Now we will write some of the forces. First, sum of the forces in X direction is equal to 0. As you see from the free body diagram, we don't have any force component in X direction. Now the second condition is sum of the forces in Y direction has to be equal to 0. So we have Fa, we have minus Wg1 plus Fb minus Wg2 minus W, and that's equal to 0. And finally, sum of the moments with respect to any point is equal to 0. I prefer to calculate the moment with respect to point A. In this case, W will generate, so the distance is A plus B plus cosine theta multiplied by D plus E. Okay, so this is the moment generated by the weight carried by the crane. Now, moment generated by the boom is D cosine theta plus A plus B. So this distance. Okay, and finally, moment generated by force coming from the ground to the track B, that is A plus B plus C, and at last moment generated by the weight of the crane, that is WG1 multiplied by A. Now from here, I can easily calculate FB because the only unknown is FB. So the expression for the FB is W multiplied by D plus E multiplied by cosine theta plus A plus B plus WG2 multiplied by D cosine theta plus A plus B plus WG1 multiplied by A, and it will be divided by A plus B plus C. From here, I can calculate the FB. Certainly, FB is equal to 625.327 kilonewtons. Now, from sum of the forces, I can calculate the FA because I have already calculated the FB. That is WG1 minus FB plus WG2 plus W. And from here, I can find the force coming from the ground to the track A is 204.673 kilonewtons.